Hi there. My name is Justin Chan, and I'm a second-year biology major from the class of 2020. Today we'll be walking through the workbook problem chapter 3.1, problem 6 on page 15. Feel free to pause the video at any time to work out your own answers, and just click play again when you're ready. So, let's go on. Question 6. I'm going to read it. An average cup of coffee contains about 125 milligrams of caffeine, C8, H10, and 4O2. How many moles of caffeine are in a cup? How many molecules of caffeine? All right, so caffeine, everybody drinks it. I love it personally myself. It's the world's most widely consumed psychoactive drug. It's definitely a daily instrument of the average college student's life. I mean, me as a freshman, I donated a considerable, or should I really say unhealthy, amount of plus dollars at the Starbucks in the UU. So what does caffeine actually look like? We don't need the structure of caffeine to solve this problem, but I think it's pretty cool to have a structural visual to grapple with. So let me get this up. I have an existing, here we go. All right, here is caffeine. We have our caffeine molecule. You would not be expected to draw the structure of this molecule with just the molecular formula, so don't worry about it. It's just for visual, as I previously stated. But let's solve this problem. Now, there are going to be some unit conversions. As you've done a lot of practice problems so far, you should automatically target the 125 milligrams. That milligrams needs to be converted to grams, so let's start with that. So I'm taking 125 milligrams. I'm going to multiply that by the unit conversion, 1,000 milligrams, 1 gram. That'll give me 0.125 grams of caffeine. So, we have our grams of caffeine. The question is asking us to find the moles of caffeine, so let's find the molar mass. Molar mass is grams over moles. So before we even calculate anything out, we know our plan of attack. If we're trying to find moles, we need to divide our grams of caffeine by the molar mass of caffeine. Grams will cancel, and we'll be left with moles of caffeine. So let's find the molar mass of C8, H10, and 4O2. This is our molecular formula of caffeine, and we're going to pull out our periodic table. So how I like to do it, I like to work it out sequentially. So I have my carbon, my hydrogen, nitrogen, oxygen. So I first need to find what is the AMU, atomic mass units of carbon. So I look at the periodic table, see that that's equal to 12.01. Hydrogen is 1.01, filling it out sequentially, 14.01, and then 16.00. So now that I know my individual masses for one specific atom, now I can multiply them by how many. So I have C8, H10, and 4O2. So I'll multiply this by 8. That will give us 96.08 grams over mole. Multiply this by 10. That will give me 10.1 grams per mole. 14 times 4, 56.04. Then lastly, multiply this by 2, 32 grams, that's mole. So I always like writing everything out, making sure I don't skip anything in the process. And finally, we'll punch everything in to find the molar mass of caffeine is 194.22 grams mole. All right, so now that we have our molar mass of caffeine, we're going to take our grams of caffeine and divide that actually by our molar mass. So let's do that. 0.125 grams, multiply that by 194.22 grams of C8H10 and 4O2. That will give us to 0.00644, wait, one more zero, or 6.44 times 10 to the power of -4. So, here is our answer to the first part. 6.44 times 10 to the -4th moles of caffeine. All right, now that we have our moles of caffeine, we're going to go through one more conversion in order to find our molecules, and that is using Avogadro's number. So Avogadro's number, 1 mole is over 6.022 times 10 to the 23rd. And we are going to use this, divide our moles by Avogadro's number to find the total molecules. So Avogadro's number can give number of atoms, molecules, protons, etc. And in this case, we're getting molecules of caffeine. So let's multiply all this out. 6.44 times 10 to the -3rd moles times 1 mole, 6.022 times 10 to the 23rd. And that will give us 3.87 times 10 to the 20th molecules of caffeine. So that's it. We first found the number of moles of caffeine in an average cup of coffee. It's right down here in the bottom right. And then we use that number of moles to find the number of molecules of caffeine in 1 cup of coffee, which is this right here.